In this example, we're going to determine the domain of the composite function f composed with g if f and g are the following two rational functions. According to our procedure, the first thing that we want to do is check our rational function g of x and determine any values of x that make g of x undefined. Because g of x is a rational function, we're going to take our denominator, which is 4 minus 2x. We're going to set that equal to 0 and see if we can find any x values that we need to exclude from the domain of f composed with g. Moving our 2x over to the right-hand side, we get 4 is equal to 2x, and then dividing both sides by 2, we're going to get x is equal to 2. So we're going to hold on to this value. This is going to be one value of x that we're not going to allow into the domain of f composed with g. In our next step, we're going to compute f of g of x to try to find any values of g that cause f to be undefined. So substituting g of x into our function f, we're going to get 1 over 2 times g of x, which is 3 over 4 minus 2x, plus 6. And if we multiply this 2 through, we should get 6 over 4 minus 2x. And I'm going to change this 6 over here so that it has a common denominator of 4 minus 2x. So inside of our numerator, we're going to have 6 times 4 minus 2x. And then it's going to be up to us to do this distribution of the 6 to the 4 and to the negative 2. This gives us 24 minus 12x all over 4 minus 2x. And now we can go ahead and add up our fractions in the denominator. So we get 1 over 6 plus 24 will give us 30 minus 12x all over 4 minus 2x. So we have a division of two fractions. We're going to multiply by the reciprocal, and that's going to give us 4 minus 2x all over 30 minus 12x. So now that we have the rational function f of g of x, let's go ahead and take the denominator of this rational function and try to determine where f of g of x is undefined. So we'll set 30 minus 12x equal to 0. We can move our 12x over to the right-hand side and then divide both sides by 12 to get 30 over 12. And we can do a simplification here. We can divide 30 and 12 by 6, and that's going to give us 5 over 2. So we need to hold on to this value of x as we move into our third and final step. Our third and final step is to consider the real number line, and we're going to remove those two values of x that are not going to be allowed in the domain of f composed with g. Our first value to exclude is x is equal to 2, and our second value to exclude is 5 over 2, and that's a 2.5, so it's over on the right-hand side of 2. I'm going to put open circles at both of these values because we're going to exclude them from the domain, and we're allowed to consider any other real number. So I'm going to shade in all of these regions here in blue. These are the allowed values of x. So we need to write this out in interval and set notation. In interval notation, it's going to look like this. Negative infinity to 2. I'm going to use a round bracket at 2. I don't want to include 2 inside of the domain. And then our second blue portion is from 2 to 5 over 2. Again, round brackets because I don't want to include these values in the domain. And then finally 5 over 2 up to positive infinity. And in set notation, this is the set of all x values such that x is not equal to 2 and x is not equal to 5 over 2.